All right, today what we're going to be talking about are definitions and conclusions for proofs. Proofs are very important in geometry, so let's go ahead and get started. There's a lot of terminology, but most of this stuff is stuff you've done before. We're just putting an official name on it. All right, so go ahead. You might need to hit pause to write all this down. But first off, if it's having the same size, shape, and size, we say that's the definition of congruent. So you just write exactly that. You can spell out definition. I abbreviated. So that's this one. For the next one, it's an exact point of a line segment that creates two congruent parts. So I kind of did my example here. That is the definition of midpoint. Next up is opposite angles made by intersecting lines. So it could be this and this. So those are definition of vertical angles because this is congruent to that and this is congruent to that. All right, vertical angle theorem is just saying vertical angles are congruent. So this is the theorem is saying that they are congruent. So the fact of vertical angles is made is here, and the theorem says they are congruent. All right, next up, you have two angles whose sum is 90 degrees. Well, if the sum is 90 degrees, that's definition of complementary. And if the angles, the sum is 180 degrees, that's the definition of supplementary. All right, so two lines that form a right angle, and you'll see the symbol for perpendicular. It's definition of perpendicular. Now, notice if it's giving you the measure or saying it's congruent, then we say that it's the definition of right angle. So if it's an angle that is 90 degrees, that's the definition of a right angle. This is just saying perpendicular any lines that form it. All right, now the next one is a line, ray, or segment that cuts an object into two congruent parts. So that's just definition of bisector. It doesn't specify what is bisecting, but it's a definition of a bisector. Next up, you have a pair of adjacent angles, so they share a side, that form a line. So that could be something similar to this. So you could have angle A, angle B. So that is considered definition of linear pair. And then for this one, the measure of angle ABC plus the measure of angle CBD is equal to the measure of ABD. So that's just saying if you're to have ABC and ABD, CBD, so that's just saying this guy plus this guy equals the big one, the big angle. And that's your angle addition postulate. You're just adding two angles. Segment addition postulate is just that you're taking this plus this and it equals the whole thing. All right, this is a new one. This is what I like to call the duh property. It's a value that's equal to itself. So if you're to have AB, segment AB is congruent to segment AB. And that's one thing, or you could say like angle C is congruent to angle C. So all of those are considered reflexive property where it's congruent to itself. All right, next up we have a triangle with a right angle. So that's just the definition of a right triangle. But now we're saying more about the measures or the congruency. So all right angles are congruent. Now this one is your right angle congruence theorem. So very similar, but this is what proves that they're congruent. All right, if x equals y, then y can be substituted, then x can be substituted for y. That's just your substitution property. And then two angles that form a linear pair are supplementary. Well, since it's telling you that it's supplementary, that's your linear pair postulate. And then parallel lines cut by a transversal form congruent alternate interior angles. So remember, an example would be like this guy and that guy. And then here, corresponding angle theorem, so is if you're to take same spot, different line. So it could be this one and that one. All right, so make sure you get all those written down. And like I said, most of these we've talked before. Now we're just going to talk about subtle differences between them. So let's go ahead and let's start trying to figure out what goes with what. All right, for number 1, it says P bisects segment CD at point E. So CD, there's your segment. Why did I write E? Oh yeah, so E. So we can say this bisects. So this is P down here. I just didn't write it. All right. So your statement is we know this, which is CE. So segment CE, make sure you put the line on top, is congruent. Actually, you go this way because since we went this way, you would go that way. All right, to segment DE. And we know that because it's a definition of a bisector. So that's all you got to do is look to see what's happening and then figure out which one best matches. All right, so now let's look at the next one. And it says your statement is we know that the measure of QPS plus the measure of S, oops, I think I meant to write SPT, my bad. There you go. Is congruent or is equal to the measure of QPT. So if you notice, we know these two small ones will equal the big one. So what that is, that's just your angle addition theorem. So it's just proving that the measure is going to be the theorem of it. So you're adding the two to make a bigger one. All right, so you're going to do this one. Try that one out. I'm going to do this one. So remember, you got to make sure you define before you say that they're congruent. So let's look at this one for statement. Our statement that we know from here is that angle 2 is congruent to angle 3, they're vertical angles, and so you can't just say they're congruent. You have to say what they are first. So you have to say what they are before you say they're congruent. But I do know 2 and 3 are vertical angles. And we know that because it's the definition of a vertical angle. Alright, so I want you to try all of these and use the vocab, and this too, and use the vocab from here to help you. And like I said, you should know most of this. It's just putting the final touches on it. Alright, so now what we're going to do, we must give a definition before stating its value. So saying if it's congruent, 90, 180, or whatever. Alright, so we're going to take this and we're going to start defining things before we say if they're congruent or not. Alright, so let's look here. I know that angle 3 and I know angle 4 are a linear pair because they share a side. They have an adjacent side. And we know that they're a linear pair because that's exactly what the definition of a linear pair is. Right? A pair of adjacent angles that form a line. Alright, now that we know that's the definition, now we can start saying what's going on here. Now, linear pairs are also supplementary. So, angle 3 and angle 4 are supplementary, and we know that because of the linear pair postulate. So this is saying what they are. This is saying what they're or what they're equal to as far as if they're supplementary or whatever, congruent. And then now, since we're talking about the actual measurement of it, the measure of angle 3 and the measure of angle 4, now we can start using the numbers or the values of it to say this plus that is going to equal 180. And now, since we're doing that, now we can say the definition of supplementary. Oops. So for this one, P is perpendicular to K. So if it's perpendicular, I know that this has to be a right angle. So that's going to be your first, is angle 1 is a right angle. Now, how do I know that? Well, it's the definition of a perpendicular. All right, so from this information, first you have to define, then you can say, then do measures or congruent. All right, so now that we've defined what it is, now we can start talking about the measure of angle 1 is equal to 90 degrees. And we know that because it's the definition of a right angle. Right, so defined, and then now we have the measure. That's not included in that. And so, like it says up here, or I guess I should say, oops, value, sorry. My thing just went crazy. So define, then let's change this. You could say measure, you could say value. So the value, I'll put here. You could put measure too. Either works. Wow, my handwriting's horrible. There you go. So defined and value. Alrighty, so it's getting a little tricky. You got a lot of vocab to think about when you're doing this. But I think the biggest thing after the actual definitions for this and the proofs is to remember you must give the definition first before stating its value. So definition of what it is first, then we're starting to do the value down here. So definition, right? So we got definition here, value here. Alrighty, so make sure when you're doing this, know these terms, and that is your notes for the day.